So, till now we have seen how Atlassian framework works. Now, let's learn about some of its drawbacks. Firstly, training an additional reward model itself brings more complexity to the process. This modeling step leads to careful tuning of additional hyperparameters. Furthermore, even though RLHF frameworks helps us aligning the preferences, it can be still sometimes less efficient and stable method. Overall, this is how our relative framework works. We have a given preference data, we use it to fit the reward model, and later this reward model is used for aligning our language model policy. But can we perform the alignment without reward model? Well, to answer this, DPO or DPO papers authors came up with a new technique that directly uses the preference data for fine-tuning the language model or aligning it with the preference data. So, simply put, DPO is a simple RL-free algorithm for training language models from preferences. So, to start with the DPO process, let's first go through how it actually came in place. This is the optimization problem that we used for RLHF. Uh, Higher the reward for any response is considered better for the model because that is what we intend to. Also, this is the policy that we are trying to optimize. This is the reference policy, and this is what this is where we are trying to limit the deviation of the policy in training from reference policy. So basically, we do not want our policy to deviate too much far away from the reference policy, otherwise it will tend to give us some illogical responses. But here we have been using Kale divergence for limiting this similarity. Now, the authors came up with this optimal solution, uh, as shown here. That is, we have rewritten the optimal solution in terms of reference policy, reward function, and a partition function. Using some normal mathematical algebra, we can also rewrite the reward function in terms of uh, optimal policy, reference policy, and partition function. Sorry. Based on this, we know now that if we have a reward function in place, we can also write human preference probability using Bartlett-Terry model in terms of reference policy and optimal policy, which we have here. It's just here is the optimal policy, this is the reference policy. Thus, now as we have the human preference probability in terms of optimal policy and reference policy, we can also rewrite our loss function in terms of it. Well, as we see here, this is pretty similar to what we already have with RLHF. We can see uh, there's some positive operation with the winner response and some negative operation for the loser response. Something similar that we had earlier. Here we are operating something with winner response and negating for the loser response. So, well, here we can see, here we are trying to maximize the probability of the winner response and trying to minimize the probability for the loser response. And also, if, as per the paper, uh, authors has termed this particular fraction, this particular value as implicit reward. So this is also we can say that it's also giving us the idea how actually the optimization is working. It is trying to limit the deviation from the reference policy, and it's also trying to maximize the winner response, maximize the probability of the winner response, and minimizing for the loser response. Now, well, for in terms of the results, uh, so authors have performed uh, evaluations on multiple tests, multiple data sets, and they've come up, they've compared with the original PPO versus DPO, their new method. So this is task one, that is control sentiment generation. So as you all know, goal of this task is given a movie review, we want to generate a positive sentiment response. Uh, we can see here uh, for DPO, this is yellow one is DPO. It has it is strictly dominating when we compare it with PPO. Uh, the reward to KL divergence ratio. So as we see, even if the KL divergence between the optimal policy and the reference policy is low, that means they are close enough, and yet DPO gives us good high reward, which is good because in case of PPO, we were not getting that good reward when policies are very similar to each other. And also, PPO GT, that is using the ground truth uh, model, a ground truth for the ground truth reward model for the sentiment analysis. When they are using that particular ground truth, even then they are not able to achieve good rewards with PPO. So this shows how powerful DPO is in terms of uh, evaluation and in terms of stability. Next is summarization. Uh, so for summarization, the task is given a Reddit post. We want to extract main points of the sample or main points of the passage. Well, this experiment is performed on varying sampling temperatures. We can see DPO, the yellow one, is pretty much stable across all the sampling temperatures. Whereas for PPO, it is highly unstable. The efficiency is decreasing. So, as we know, increasing the sampling temperature, it will lead to higher probabilistic results and tend to give more unstable model. But even with that, DPO is still performing pretty well when compared with PPO, and as well as if we compare it with best of 128, it is giving us comparable results. So best of 128 as per the paper is when you are trying to extract 128 responses and just take best of it, like best responses. Uh, taking considering a best of 128, so it could be pretty demanding, pretty computationally demanding method, because we are trying to generate 128 responses and then figuring out what's the correct answer. Even with this scenario, task 3, it's single turn dialogue where we are giving human query and we want to get a proper response from the LLM. Even with this case, DPO is performing pretty good and comparable enough with best of 128, such highly computationally demanding method. This shows that DPO is working quite well on different tasks. Authors of the paper analyzed the performance of the model over the course of the training steps. As we can see here, the model remains fairly stable even for different sampling temperatures for this training steps. As we see here, overall, it is pretty much stable for different sampling temperatures. even converges relatively quickly for both sampling temperature. This shows how DPO is much more stable and efficient method for aligning the language model. So that's all for DPO paper. Moving on, next paper that we are going to talk about is Zephyr. The key highlights of this paper are that the model has used a small different AI models for generating the preference data, and also uh, a unique distillation method is used for curating good data set for fine tuning. So this is how Zephyr what training looks like. We have already seen how Instruct GPT training looks like. This is in a similar format. We have divided the training steps in three parts. First, we have the fine tuning step, which is the still fine tuning. So the goal here is to curate a good high quality response that will be able to capture uh, the capabilities of the teacher model. So teacher model that was used for Zephyr training is GPT-4. As we see here, we have some initial seed prompts, and our aim is to curate this data set using teacher model. How we do that? Let's say we take one of the seed prompt, we pass it to teacher model, then generate the response. Once we have the response, we pass both the prompt and the response to the teacher model and instruct it to refine the instruction. And so on, then we continue this process for a couple of steps, and then we can generate a good high quality response dataset. This dataset will be used further for fine tuning our model. That is what we call the first fine tuning step. We generate a dataset, we curate a dataset actually, and then use it for uh, fine tuning the language model. So that's what we have. UltraJet is the dataset that was generated, and then we use it for fine tuning the model. That's what we call distillation supervised fine tuning. That's the first. Now, moving on to the second step, that is response generation and AI ranking. So, this step 2 includes using of a teacher model again, and same teacher model was used with this step 2, and generation of preference data using other models. So how we do that? We use a prompt, we pass it to four different language models, and then we ask them to generate a response. Each of them generate a response, and teacher model is used for scoring the response. We have this like S1 is the first score where model is trying to evaluate based on the prompt and the response and score it accordingly. Once we have this course ready, we will curate a data set that consists of the prompt that was used, the winner response with the highest score, and a loser response. Now, the catch here is for the loser response, we've not selected the response with the least score. Rather, we randomly select one of the response from the remaining three candidates. So this was the chosen approach because they wanted to include diversity in the dataset. So that is what we have with this second step. We we sample prompts, we pass it to different models, and use GPT-4 for binarization. This data set that was generated is also named as ultra feedback. Now, moving to third step, that is DPO. Uh, so DPO, we have already seen how DPO works, and Zephyr is model that is utilizing DPO method for aligning the language model with the feedback data. So the training procedure is pretty simple. We uh, we calculate the probability of winner response and loser response with respect to the fine-tuned model that we got with first step. Then we also try to get we get probability from DPO model that we're trying to update, and then back propagate using the this equation. We have already seen how we got this one, uh, maximization of the winner response and minimizing for the loser response. This is same as what we have already learned with DPO. To look at some of the training details, uh, the fine-tuning experiments were performed on Mistral 7B. So this is the state-of-the-art model for 7 billion size category models. So that's why authors chose this model. Uh, they've also used transformer reinforcement learning library for fine-tuning and for optimizing memory and improving the training speed, they've used Deep Speed 03 and flash attention mechanisms. Now, moving forward to the evaluation part, multiple datasets were used for evaluation purpose. Here is the gist of the dataset. Uh, First, it was empty bench that has multi-turn response benchmark. It includes 160 questions across 8 different area of knowledge. Uh, Mainly, it has a one initial question. Model is supposed to respond to that, and it has a predefined second question as a follow-up question, and then that is how uh model will generate second response, and then GPT-4 will be used for evaluating the uh, combination of the responses. There's one more, that is alpaca event, that is a singleton benchmark. It includes 805 questions across different topics, mostly that's focused on helpfulness. And here also GPT-4 is used for evaluations, but here we perform pairwise win rate comparison. So as we see here, for both the metrics, Zephyr outperforms the 7 billion size model category, and it provides highest scores. Yeah, you can see here. Also, if we compare it with some of the higher size data sets, even it is outmatching them. And if we compare it with GPT-4, it is still giving us pretty comparable results that shows how much well trained this model is, even if it's such a small size model. One thing to note here is that alpaca evil results could be somewhat misleading because uh, the data set doesn't involve a huge variety of the uh, questions that are needed to be evaluated. So this is what we do for evaluation with empty bench. It has questions across different domains, and we can also divide it across them. And as we see here, Zephyr performs very good and comparative enough for multiple categories like role play, writing, humanities, STEM, even with extraction. But it performs very bad when it's about coding or math. It's even worse than most of the models. So we should have this thing in mind, what area or what thing that we are trying to use the model for, and then we can use appropriate model. So one thing to note that is we should keep in mind which area we are working on and which model excels in that area. Uh, Next, for evaluations, different open LLM leaderboards were also used. Mainly, these are academic type data sets, have like multi-class classification questions. Even with this data sets, we can see that Zephyr is outperforming the 7 million size category, and as well as it is giving good competition to even higher size models. We can see that it is almost giving similar results to good high sized model. Now, one more ablation study was provided by the authors of Zephyr to understand how much the optimization was helpful, how much the distillation was helpful for the Zephyr training. So they've performed this four step training process. First, directly use the Mr. module and fine-tune it using DPO for one epoch using the ultra feedback data set. And as we see, the distillation step was not performed, and it has highly uh, affected the model performance. Next, the fine-tuning step was performed using UltraJet for one epoch, and we can see a good increase in the results, which shows us how much effective the data set is and how much it helps the model for uh, correctly predicting the answers. Next, we did perform one epoch of fine-tuning using UltraJet and second epoch of ultra feedback, and we see a little drop in the performance. So that's not good for the model. And finally, we perform one step of uh, uh, fine tuning using UltraJet and one step of DPO using ultra feedback, and that gives us maximum results, which shows that indeed DPO and distillation both are helping our model for improving its understanding and aligning the uh, preference data. Yes, that's all for Sapphire. Thank you.